but I think it's like simplifying identities or something like that.
Okay.
The first one that I have is secant y sine parenthesis pi over 2 minus y.
Secant. I'm sorry, would you repeat it again?
Secant y sine, and then in parentheses pi over 2 minus y.
Okay.
And that's it.
Let's talk about cofunctions. What is the cofunction of sine?
Cosecant.
Cosine. In other words, cofunctions are just the trig function with the word co in front.
Okay.
And the property that cofunctions share is this one. And likewise, cosine of theta is equal to the sine of pi over 2 minus theta. Notice that sine of 30 degrees is the same number as the cosine of 60 degrees. They're both 1/2, right?
Yeah.
So this applies between sine and cosine, tangent and cotangent, and secant and cosecant. So if I take this function right there, I can replace it with cosine of y. So now I have secant y cosine of y, and secant of y is 1 over cosine y. In other words, this becomes 1 over cosine y times cosine y. Okay.
Okay.
What else?
The next one is 1 minus cosine squared theta over sine theta.
Okay, what's 1 minus cosine squared theta equal to? The Pythagorean identities.
I have no.
Hold on, I'll go ahead and write them.
Okay.
Sine squared plus cosine squared equals what? 1.
Or 1.
Okay. The problem is that when you're working with trig identities, you rarely see it as sine squared plus cosine squared. They're not going to make it that easy. What they do is usually subtract one of these from the left side, and you're always looking at 1 minus cosine squared or 1 minus sine squared. So the identity for that is sine squared. Now you have sine squared over sine, so this whole thing becomes sine theta, because you have sine squared divided by sine.
So
Okay.
1 minus cosine squared is sine squared?
Yeah, in other words, if you do the algebra on that identity over there, let's talk about the other two Pythagorean identities. This one is the most standard one. That's the first one everybody learns. That's the one you're expected to know even if you take the ACT test. Okay? The other one looks a little different. Tangent squared plus 1 equals secant squared. That one you just have to memorize. Okay?
Okay.
The third one you can always figure out from the second one. The third one is cotangent squared, in other words, the cofunction of tangent squared, and the cofunction of secant squared, which is cosecant squared. So to memorize the third one, if you know the second one, just make the cofunctions of each trig function and you've got the third one. And likewise, you're not usually going to see that in an identity. What you probably are going to see is something like secant squared minus 1. That's equal to tangent squared. Or tangent squared minus secant squared, that's going to be equal to minus 1. So you might run across that in one of these problems. But obviously you got to start from memorizing the 3 Pythagorean identities, and then just always remember that these are liable to be algebraically manipulated for the problem that you're looking at. I'll leave those up there for a moment. What's the next one you have? Maybe we'll need one of them also.
Before we go to the next one, what's sine squared theta over sine theta reduced to? So that just becomes sine theta?
Yeah. In other words, sine squared theta is the same as this. That's what sine squared theta means. Sine theta times sine theta.
Okay.
So you're left with that.
Alright.
Sine cubed theta over sine would reduce to sine squared theta. So it behaves just like polynomials.
Next one is, alright, this one is simplified to either 1 or negative 1.
Okay?
The first one is sine x in negative x.
Sine x, what's that?
Cosecant negative x.
Okay? What's important here is the odd-even property of trig functions. Odd trig functions are sine and tangent. And what that means is the sine of negative x is equal to negative sine of x. Tangent of negative x, same thing. It's equal to negative tangent x because they're both odd. What is even is cosine. If I take the cosine of minus x, I get cosine x. So cosine is even. Now, each of these reciprocals is the same odd or evenness of its reciprocal. So cosecant of negative x, because cosecant is the reciprocal of sine, then it's also negative. I can rewrite this as sine x times negative cosecant of x. Because it's odd.
Oh, yeah.
And cosecant x, or sine x if you prefer, is 1 over cosecant. So I can replace that with 1 over cosecant x. And now I've got negative cosecant over cosecant, negative 1. Okay. What's the next one?
Cotangent negative x, tangent negative x.
Okay, so how does this convert based on the odd-even properties? In other words, cotangent of negative x is the same as what? Is it the same as cotangent x, or is it the same as negative cotangent x?
So that'll be the same as is cotangent x.
It's odd. In other words, both of these are odd, which means it's negative cotangent x times negative tangent x. This is the same as negative 1 over tangent x, and I've got multiplied by a negative tangent x, the negatives become positives, and I got plus 1, because I got a negative divided by a negative.
Okay. Okay, the next one, the next couple, simplify the expression to either a constant or a basic trigonometric function.
Okay.
And work well graphically.
Okay.
And the first one is tangent pi over 2 minus x.
What can I substitute for that? Before I even go any further, what's that the same as?
I'm not sure.
That's the same as its cofunction. In other words, that's cotangent is both the reciprocal of tangent and it's also the cofunction of tangent. It's the only two that share that property, that they are not only the reciprocal of one another, but they're the cofunctions of one another. Notice that secant is not with sine or cosine. Secant is the cofunction of cosecant, but it's the reciprocal of cosine. Okay, what's the rest of it after tangent of pi over 2 minus x?
Cosecant x, and all of that over cosecant squared of x.
Okay, well, this I'm going to replace with cotan of x. This just knocks down this exponent by 1. So now I have cotan x over cosecant x. They wanted you to do what?
Simplify the expression to either a constant or a basic trigonometric function.
Okay.
And support the result graphically.
Okay. Cotan of x, what's its quotient identity? In other words, the trick here is that I can express cotan in terms of sine and cosine, and I can express cosecant in terms of sine and cosine. So that's what we want to do. In other words, it's cosine over sine is cotangent.
Well, why did you cross out the cosecant on
Because I had a cosecant squared on the bottom.
Oh, it's right.
Okay, so cosecant divided by cosecant squared is the same as 1 over cosecant.
Okay.
Okay, and this cosecant is the same as sine, right?
Yeah.
So now those cancel, and the basic function it comes down to is cosine of x. I might not have been perfectly clear how I did that there. I changed cotan to cosine over sine, and then I'm dividing that by cosecant, but cosecant is 1 over sine. So now I flip this and multiply. Sines cancel, and I'm left with cosine. Okay?
Yeah.
What else? Oh, you were, they wanted you to prove this graphically?
Yeah.
So
Yeah.
that's easy enough to do. Here, I'll do it on Wolfram Alpha, just because it's easier for me to put it in on Wolfram Alpha, I think. So we would expect to see a cosine curve. I'm going to do tangent of pi. Hold on. You still there?
Yeah.
My sound kind of got funky on me. Let's see. Tangent of pi divided by 2 minus x times cosecant x all of that divided by cosecant squared. Oops, hold on. You have to do this kind of a strange way also. Alright. See if it recognizes what I put in. Tangent of pi over 2 minus x times cosecant of x times all over. And notice what we have. We have the cosine curve. It simplified it for us also. That's interesting. I didn't realize Wolfram Alpha would do that. Huh. That's pretty handy, huh?
Yeah.
That it'll actually go through and use its own trig identities to simplify it to cosine x. But that's definitely the cosine curve. Okay. What next?
Next one is squared.
I'm sorry, I didn't hear.
Secant squared x minus tangent squared x over cosine squared y plus sine squared y.
What's the bottom equal to?
So that'll be 1.
Okay. What's the top equal to? Remember that second Pythagorean identity was tangent squared plus 1 equals secant squared? So therefore, what would secant squared minus tangent squared equal?
So that'll just be 1.
Uh-huh.
Okay.
Tell you what, let's review our 11 basic, most fundamental trig identities. Do you know the reciprocals?
For
What's the reciprocal of your top three? What's the reciprocal of sine?
so that'll be cosecant, or 1 over.
What's the reciprocal of cosine?
1 over secant.
And tangent is 1 over cotangent. So there's the 6 reciprocal identities. And I say 6 because obviously if sine is equal to 1 over cosecant, then cosecant is equal to 1 over sine also. So there's 3 more. Okay? But you only really have to memorize the first 3. Okay, let's go tangent. What's the quotient for tangent? Quotient identity?
What's the quotient identity?
Sine over cosine.
Oh, okay.
Okay? And that's the only one you have to memorize because the only other one is cotangent. So what would cotangent be?
Cosine over sine.
Uh-huh. So in other words, these 11 key identities, you only have to memorize about 5 of them, or 6 of them. Again, there's the trig ones are, that one you got to memorize, and you got to memorize the second one. What's the second one? Tangent squared plus 1 equals secant squared. That's, in other words, we used the second one on the last problem. Because the last problem gave us secant squared minus tangent squared. Right?
Oh, yeah.
So that's where the second one. And the third one, don't look it up, don't memorize it. Tell me what the third one is. It's based on the second one.
Squared minus 1 equals tangent squared.
Cotangent squared plus 1. Everything's exactly the same, only we're using the cofunctions. Equals cosecant squared. In other words, the third one is the same as the second one, only put co in front of the tan and co in front of the secant. So you've got your 6 reciprocal, you've got your 2 quotient, and you got your 3 Pythagorean. Those 11 identities you want to have memorized well. Because all of your problems that you're getting are based on those 11 identities. And then also the 6 cofunction identities. In other words, sine of pi over 2 minus x is the same as cosine of x. So those 6 cofunctions, but those are pretty easy. Those 6 identities, it's just pi over 2 minus x for each one of them. Okay, so what's the next problem you have? Oh, on the last problem, when we wanted us to graphically verify that, what would the graph of that look like?
Would that just be like a straight line at 1?
Yeah, that's exactly what it would be, is a horizontal straight line at 1. In other words, this is equal to f of x, or y,
Okay.
ignoring the y and the x down here. F of x, the vertical axis is going to be equal to 1. So it would be same as graphing the line f of x equals 1, which is a horizontal line, as opposed to x equal 1, which is a vertical line. All right. What else?
Okay, this one says use the basic identity and change expression to one involving only sines and cosines.
Okay.
Then simplify to a basic trigonometric function.
Okay.
The first one is sine x, cosine x, tangent x, secant x, cosecant x.
All right. Let's change everything to sines and cosines. So that's already sines and cosines. So to change tangent, what does that become?
Sine over cosine.
Okay. Sine over cosine. How about secant? What's that?
That'll be 1 over sine.
1 over what?
1 over cosine.
Okay. And cosecant?
1 over.
So that cancels with that. That cancels with that. And I end up with sine over cosine, which converts to what single trig function?
Tangent.
Okay, go ahead.
Next one is secant squared x cosecant x over secant squared x plus cosecant squared x.
Okay, let's convert everything to sines and cosines. It's the numerator. The numerator become.
So the secant squared that be 1 over cosine squared.
And cosecant?
1 over sine squared.
1 over just sine. This wasn't squared in the numerator, was it?
No, no, sorry.
Okay, it's okay. And then divided by what? Secant squared again is 1 over cosine squared.
And then that one will be 1 over sine squared.
Okay. Now it becomes an algebra problem. Let me think about this for a second. Okay. The bottom is being added, the top's being multiplied. So the top's easy enough to do. How do we add 1 over cosine squared to 1 over sine squared? Need a common denominator. What's it going to be?
Would we have to make some tangent or?
No, just to get a common denominator, you can always get it by multiplying. Okay, so cosine squared sine squared is my common denominator. And up here, I need a sine squared plus a cosine squared. In other words, these two things right here add to what I've written down there. See how?
Not really.
Okay, let's go through how we're going to add that. This is key here. You need to be able to do this. Let me do it separately. I'm adding 1 over cosine squared to 1 over sine squared. Well, I know the common denominator is the product of those two. So it's cosine squared sine squared plus same common denominator over here. Now, what has to go here? Well, it's got to be sine squared, doesn't it? In other words, I'm not changing that fraction, I'm just giving it a different denominator. So if I divide that into my common denominator and multiply by the numerator, I get what needs to be there. You see where this is the same as 1 over cosine squared?
Yeah.
Okay, and then on the right side, I've got to put a cosine squared in the numerator. And that's the same as 1 over sine squared. So it's really no different than if I was adding 1 over x and 1 over y. Notice how I would do it. Common denominator is xy. X goes into xy, y times 1. I got to put a y there. I got to put an x there. So adding trig functions is exactly the same as adding polynomials. You find a common denominator and make sure your fractions, in other words, make sure that's equal to that. Okay, now let's go back to that problem. Go up here. Okay, so what we decided, let me erase this, was that this is the same as sine squared plus cosine squared all over sine squared times cosine squared. Now, sine squared plus cosine squared, what can I replace that with?
1.
Now let's operate by flipping the denominator and multiplying. So I'm going to multiply by sine squared cosine squared. My cosine squareds cancel. My sine squared over sine becomes sine. And this is a good exercise because a lot of the times when you're trying to simplify trig functions, you usually, or very frequently, you want to put everything in sine or cosine, if you can. I mean, not always, but most of the time you want, if you're verifying trig identities and you can't figure out how to do it, usually the answer is put everything in sines and cosines and go from there. So this exercise of converting everything into sines and cosines is quite useful when you get to verifying trig identities.
Okay.
You haven't actually gotten there yet, have you?
No, we haven't.
Okay, that'll be fun. But it is actually fun. Its total purpose is to get you to memorize your 11 basic trig identities. That's the only reason everybody studies verifying trig identities. There are no real-world problems where you have to verify a trig identity. What it is kind of a practice made up by mathematicians, a practice drill to get you to learn those 11 identities. And if you do a lot of work with verifying trig identities, I guarantee you'll have them memorized by the time you're done. You can't even begin to work on them unless you know them. So, what else you got here?
Next one Combine the fractions and simplify to a multiple of the power of a basic trig function.
Okay.
The first one is sine x over cotangent squared x minus sine x over cosine squared x.
That it?
Yeah.
Okay. How am I going to subtract these two fractions?
Find the common denominator.
Okay. What is it? Here, let me do it like this. Remember, it's always, a common denominator is always found by multiplying the two denominators. Not always the least common denominator, but usually with variables or polynomials or trig functions, it's the only common denominator. So cotangent x times cosine squared x, that's our common denominator. Okay? You with me?
Yeah.
Now what goes in the upper left? In other words, what goes right there?
The sine x times cosine squared x.
Yeah. And whenever you do these, it's always a good idea to just make sure that you have not changed that fraction. In other words, I can see by looking at this, the cosines would cancel and I would have sine x over cotangent squared x. And that's the goal, is to not change it. So what goes in the upper right?
So that'll be sine x times cotangent squared.
Yeah. Okay, now we have a common denominator, so we can operate on the fraction. There's my common denominator. And the numerator. What can I do with the numerator? Let's I can factor out a sine x, leaving cosine squared of x minus cotangent squared of x. What's our assignment here to reduce this to a single trig function?
Combine the fractions and multiply multiple of a power of a basic trigonometric function.
Okay. You think about this for a moment. Well, cotangent squared, let's convert everything to sines and cosines and see what we got. Okay, this is already sine, that's already cosine. Let's convert cotangent squared to sines and cosines. What's that equal to in terms of sines and cosines?
Like cosine squared over sine squared.
Okay. And in the bottom, what's cotangent? Cosine squared over sine squared. Alright, now this becomes cosine to the fourth over sine, so let's do that. Now, because I have a single rational function as a denominator, I can flip it and multiply. So I'm going to multiply this whole numerator by sine squared over cosine to the fourth. With me? If you lose me at any of these steps, holler.
Alright.
Sine times sine squared is sine cubed. let's distribute that sine cubed to both of those terms there. So we've got cosine squared x sine cubed minus cosine squared times just sine. All of that over cosine to the fourth.
That cancel out the cosine then?
No, let's see. If we take our numerator, we can factor out a cosine squared and a sine. So the new numerator becomes, I may have done this the long way, but that frequently is what happens with these trig things. You can take the long route. That becomes sine squared minus 1 all over cosine to the fourth, right? Now I can cancel this cosine squared out with two of those. Sine squared minus 1 is equal to what? If sine squared plus cosine squared equals plus 1,
this will be negative cosine?
yes, negative cosine squared. Well, now I can take that cosine squared, cancel it out with that cosine squared, and I'm left with negative sine. And like I said, I might have done that the long way, and there may have been a shorter way to get to that answer. But that's what happens when you're doing verifying trig functions also, is that you don't always take the shortest path, but as long as you get the answer, it's generally sufficient. I'm trying to think if I could have done this easier. I don't think so. The instructions were to combine the fractions, right? In other words, subtract the fractions first?
Yeah.
Yeah, so the only way to subtract this fraction from this fraction is with a common denominator. And then once you get that far, once you get down to here, I think you kind of have to go the route I went also. So I don't know if I did do it the long way. I might have done it the only way. Okay?
All right.
Got another one of those beauties. Mainly, this is hard algebra. And in other words, this is as much algebra as it is trig. It's like if I gave you an algebra problem, 1 over x plus 1 over y, all divided by 1 minus x over 1 plus x minus 1 minus y. You know, this kind of a problem here, that's a tough algebra problem. But very doable, as long as you know how to find a common denominator. You can do this problem. Same thing with trig. Trig is no different. Replacing these with trig functions, the algebra then becomes the problem. All right. Go ahead.
The last one is sine x over 1 minus cosine x plus 1 minus cosine x over sine x.
Okay, I'll let you work me through this.
Okay. Let me just finish writing. So first, we'll need the common denominator.
Which is?
1 minus cosine x sine x.
And it's better to not distribute these, and I'll show you why in a minute. Until you have to. Don't automatically distribute that, because a lot of times you won't want it distributed, you want it factored. Okay?
Okay.
And I think it'll be demonstrated why here. Okay, what goes here?
Would be sine x squared.
Sine squared x, and there is a difference.
Oh.
Okay? Sine squared x means sine x times sine x, not equal to sine of x squared. Sine of x squared is precisely that. It's the sine of whatever x is squared. It does not mean sine x times sine x. So that distinction is important. Okay, so we got sine x there. What do we have over here?
It'll be 1 minus cosine x squared, or like all that in parentheses and then square that. Yeah, would that work, or could you also do that with cosine squared x?
Well, no, that's correct. The way we've let me in fact just be clear here. Let me multiply that out. Not multiply it out, rather. Let me write it like that. Now, that's the same as what's above, right? It's easier to see now, because this would cross out with that, and I'd be left with that over that, which is that. Okay, now we do need to multiply that together, and I don't know if you can see why, but we're going to end up with a 1 plus cosine squared plus a middle term, and then I'm going to have sine squared plus cosine squared that I'm going to be able to replace with 1. So let's multiply this two out. What does that become? What's 1 minus cosine x times 1 minus cosine x?
So 1 minus 2 cosine x plus cosine squared x.
Okay. Now, because we have a common denominator, I can do this. Right? Turn it into one fraction.
Oh, yeah.
Okay. Now, I'm going to combine the sine squared x and this cosine squared x here and replace it with 1. Now I'm going to remove the parentheses. 1 plus 1 becomes 2. Now factor out what from this? What can you?
Factor out the 2?
Yeah. And I'm left with 2 times 1 minus cosine x. Okay? Now you can see why I didn't want to distribute the bottom.
Yeah.
Because I can easily see that. Whereas if this bottom was multiplied together, it wouldn't be as easy to see that. So you end up with, now this is another kind of a funny convention. That's not our answer, because you don't give an answer with a trig function in the denominator if you can avoid it. That's the answer. 2 cosecant x. Okay? In other words, there's nothing fundamentally, sine is not more fundamental than cosecant.
Yeah.
It's the same, it's just a different trig function, and like I said, if you can give it without a denominator, you always want to do it.
All right.
Okay. So you are just about ready to begin verifying trig functions. That's going to be your next step.
Okay.
And you'll probably be given a whole page of those to do. Most every trig book I have has a couple of pages of verifying trig functions. And by verifying, I basically mean if you want to prove that that's equal to that, you take this and you make it look like that. In other words, tangent is equal to sine over cosine, so I've verified that that's equal to that. Only verifying trig functions are much more complicated than just a simple identity like this. But it still comes down to knowing your 11 basic identities, and plus the 6 cofunction identities. But between those 17 identities, you'll be able to solve all verifying trig function, at least at this point. You haven't gotten sum and difference yet, or double angle identities, or half angle identities. When you get those, there's a bunch more to memorize. But usually when you're working with verifying trig functions, they have you do that before you learn those others, just because otherwise it would make it almost too hard to have to draw upon 25 different identities. They usually just make you draw upon the first 11. The reciprocal, the quotient, and the Pythagorean identities. Those are your key ones. Those are the ones that you, without a doubt, want to have memorized. What else? Any other questions?
No, that's one.
Okay. Any general questions about these trig identities?
No, I think I got a pretty good handle on it from that.
Okay. Sounds good. I will talk to you next week.
What do I owe you at this point?
108. I was just looking, and there's been 3 sessions since that other check.
Okay.
Okay? All right. Have a good week. I'll talk to you next week.
All right.
Bye-bye.